If we were asked to increase 150 by 10%, there's a number of different ways we could do this. The most common way is to work out 10% and then add it on. So to find 10%, we take our starting amount, 150, and we divide it by 10. That gives us 10%, so that's 15. And then if we're increasing it by that amount, we take 150, we add on the 15, and that will give us 165. So that's 10% bigger than 150. So that's the most common way, as I said, to complete that calculation. But there is another way we can complete it using the multiplier method. So same question, we're starting with 150, and we're going to increase it by 10%. But this 150 is really our starting amount 100%. And we're looking to add on 10%, so we're actually looking now for 110% of our starting amount. But how do I find 110% of 150? Well, finding 110% would be the same as dividing by 100 and then timesing by 110. And I can actually just write that as I multiply by the fraction 110 over 100. Because to complete this, we would do 150 divided by 100 times by 110. So that calculation would give us 110% of 150. But we could, to make it a little bit easier, we could simplify this fraction. So if we do 110 divided by 100, that would be the same as 150 times by 1.1. So this is what's called the multiplier, because if I multiply any number by 1.1, it will give me 10% more than my starting amount. So 150 times by 1.1 would give us the same answer as earlier, 165. So that's an example of using the multiplier to increase something by 10%. So if we look at a second example where we're decreasing, so if a camera is normally £210, but I decrease it in a sale by 20%, what's my final amount? So 210 is our starting amount 100%, and we're going to reduce the price by 20%. So we're really looking for 80% of our original price. So how do I find 80% of 210? I multiply it by 80 over 100. And then again, we simplify this second fraction down into a decimal. So we get 210 multiplied by 0.8, which if you type that into your calculators would give you 168. So the multiplier to reduce something by 20% is 0.8. Hopefully some of you are wondering, what's the point? I can already do those percentage changes myself without using multipliers. Well, the value of using multipliers is obvious when we're completing lots of percentage changes in a row. Let's look at an example where the ice caps are 9 meters thick, and each year they decrease by 15%. So if we wanted to know how thick they would be after 3 years, we could use multipliers to help us reduce that. So we'll start with 9 meters, and to decrease by 15%, our multiplier would be 0.85. So we complete that using our calculator, and we would get 7.65. Then to find out the total in year 2, we would do 7.65, and then reducing that by 15% by multiplying by 0.85. And that would give us 6.5025. So that's how thick the ice caps are after 2 years. To find our total after 3 years, we do 6.5025, and we'd again multiply by 0.85. And that would give us our final total of 5.5 527,125. So let's just round that to say 5.5. So the ice caps after 3 years would be 5.5 meters thick. Using multipliers helps us to simplify this down. So we're not actually going to do these three calculations. There's a much neater way of writing this. So let's have another look at what we were doing. So we started with 9 meters. To find how thick they were after 1 year, we multiplied that by 0.85. So that was after 1 year. To find 2 years, we took our answer and we multiplied it by 0.85 again. And to find the total after 3 years, we multiply it a third time by 0.85. Now if you think back to your index laws, if we're multiplying 0.85 times 0.85 times 0.85, we could actually just rewrite that as 9 times 0.85 cubed, or to the power of 3, because we're multiplying 0.85 times 0.85 times 0.85 3 times, which gives us 0.85 cubed. And that would straight away give us our answer of 5.5. And if you think how you'd have to calculate that without using a multiplier, you'd have to find 15% each time, subtract it from your total, and then continue to do that 3 times. And I mean, that would be possible for 3 years, but if I asked you how thick the ice caps would be after 30 years, using multipliers, all we'd have to do is 0.85 to the power of 30, and that would give us our total. So that gives us a formula for using multipliers to do what's called compound percentage changes. So we have our starting amount, I'm just going to call that our start, and we multiply that by the multiplier, and that's done to the number of changes, or most often the number of years. And this formula will give us any compound percentage change if we just do the starting amount multiplied by the multiplier to the power of the number of years.